Hello everyone, welcome to this video by 𝗏𝗏𝘀𝑚𝑒. So we will continue our course on data structure and algorithms. So in the last class we discussed about the intuition of time complexity and space complexity. We are yet to cover that in detail, that how you determine whether a code is of which time complexity. Okay, and let's say if you're given a code of a worst time complexity, can you convert that to a better time complexity? So those things we will be covering in this course in full detail. Right now I'm just setting up the tone in this course so that you guys understand, because I know a lot of you guys might not even have heard about DSA, right? You might have just written some Python codes in life and you don't know what is the science behind it, what is the science behind programming, right? So this course is about to realize you this thing only. That's why I'm going little slow initially, and once we understand few basic principles, we will pick up speed. Okay, so now we are just getting familiar with some of the terms and technologies like which you will be hearing online, or for example if you read any online article about DSA, you will hear about like big O, big omega, big theta, and there are a lot of things, time complexity, space complexity, merge sort algorithm, those kind of things. So I'm just initially giving you an introduction to these particular topics, and then we will deep dive into each one specifically. So now in this video, let's discuss about the three major notations that are used in data structure and algorithms. So they are called as big O. Okay, so big O we generally see, so it is order of. O means order of. And there is big omega and there is big theta. So any algorithm is given three notations. It is big O, big omega, and big theta, and we'll be discussing about that in detail in this particular video. You would have seen that in most of the cases we see big O. The big O notation for this is let's say for example ON, or you would have seen ON square, or you would have seen ON, for example log n, these kind of things. So similarly, just like O, there are simply omega as well, there is theta as well. Okay, so we will let's discuss about what all these things are in full detail. So let us assume for this particular scenario we have a list. Okay, so let us say we have a list of 5 elements. So let us say this is 10, this is 20, this is 30, okay, this is 40, and this is 50. So let us say this is the list that we are having, and our objective is to find the number. So we have to find a number, let's say target, that is equal to, for example, let's say we have a particular target which is given, and we have to find that if that element exists in this list or not, and if that element exists, I have to get its index. So like by index, what I mean, for example, this is 0, this is 1, this is 2, this is 3, this is 4. So if I will change p with time, and if I find that element here in this particular list, I have to return its index. Okay, so now so there are few scenarios possible. So for example, what will be happening is that suppose that number that you are looking to search is 50. Okay, let's say p is equal to 50. So what will you do? First of all, you will simply, so let's write down a code for this. So let us try to understand this through a code. For example, let's say we have this list which we discussed, list is equal to 10, 20, 30, 40, and 50. This is 5 integers, and let's say there is a target variable. For example, let's say right now it's 50. I have to create a function which checks if this particular target is present in this list or not, and if it is there, it should return its index. So how will you do that? Target search, let's name our function target search, and it is taking list, okay, and it is taking target. These are the input parameters. Now how will you run this particular function is that you will do for I in range length of list, correct? So you will do something like this, and for I in range of length of list, if list of I, if this is equal to target, for example, if this is equal to target, what do I have to return? Let's return the index. So return I, otherwise return -1. So if, for example, if you don't find, then return -1. Now let's try to run this particular function target underscore search, and so the variable is list and target, right? So list and target that we created above. Now for 50, it will what it will return? It will return me 4. Let us say I change this to 20, and it will now return me 1. Okay, so let's do one thing. Just let's move it here only so that I can show you multiple scenarios together itself. Okay, and now let's say number 60 comes, which is not present in the list. So what it will return? It will return you -1. So what is happening here in this particular code? So that depending upon the number that you are searching, the code that we have written, how is it working? That we are iterating for I, and like we're running a for loop. So how is it running? That we are running a for loop, and our for loop is working like this. It is going from, first of all, it is going to element 1. Okay, then it is checking, is it equal to the target? If yes, it will return, otherwise it will move to the next one. Then it will move to the next one till it finds that particular number, which is our target. So in short, we are going to each element one by one, and it is taking so we are going to each element one by one, and if it finds the element, it is returning the index. Simple. Now what is happening here? So let's create a new screen here. So let me show you what let's discuss the number of steps, number of observations, or so let's say this list was 10, 20, 30, 40, and 50. So let us say we have different scenarios. So first of all, let's say we have to search 10. Second, we have to search for 30. We have to search for 50. And fourth scenario, let's say we have to search for 70. So what will happen? Now, when you are searching for 10, you will start here and you will find this immediately. The first element is 10 only. Okay, so you don't need to go through all. So what are the number of, so for each scenario, let's calculate number of steps that algorithm is going to take. So in the first scenario, it only needs to do one step. In the second scenario, it needs to do 30. So 1, 2, 3. So how many steps are involved? There are 3 steps involved. In 50, it is going 1, 2, 3, 4, 5. It will do 5 steps. Okay, and in the 70, it will again do 5 steps, and even if after 5 steps, it will tell you that, okay, I'm not able to find this number. So what are we doing here? We see that to find through this algorithm, to find the target value, we might have to take different steps. So what is the worst scenario here? Like what is the worst observation or number of steps? That is 5. Okay, so this is the worst scenario. Correct? What is the best scenario? The best scenario will be that you find the number at start of algorithm only. So this is your best scenario. Okay, and what is your average scenario? It's your middle one, because there are total 5 elements, and out of that you just took 3 steps. So you found the average scenario. Now, depending upon, there can be, like, you can encounter different type of numbers. So they will either fall in best, average, or the worst scenario. Correct? And this is what the concept of the 3 notations that are discussed in data structure and algorithms. This one, the best, it is called lower bound, and this is denoted by big omega. So this is denoted by big omega, and this is called the best time complexity for any algorithm. And this is the third, the middle one, 3, it is called as the big theta. Big theta. And this is particularly called, you can say tight bound, or you can say average, or a typical case. So you can say this is average time complexity, and this is your worst time complexity, and this is denoted by big O. This is your worst time complexity. So let's bring up a new page here. So we saw that there are three scenarios. There is omega, okay, then there is theta, and then there is big O. So what is big O? Big O is the worst scenario to find of any algorithm, correct? And big omega is the best scenario of any algorithm in time complexity, and this is the average scenario of any time complexity. Okay, now whatever coding you do, every algorithm or every code has these three attributes. Okay, now imagine, to make your code generally better, what you should actually target. You should target, okay, best is fine, average is fine, but I should target that my worst time complexity should be improved, correct? So that is why in most of the cases or scenarios or the questions that we will be doing, we will see that our focus will be on solving the big O, okay, so that we can improve its worst time complexity. Similarly, like there can be, so we will discuss a big O in detail, but I'm just telling you the intuition to find that for any algorithm, there are multiple approaches, there are multiple ways to determine time complexity. There can be a best, there can be average, there can be a worst. You can create your own time complexity as well. For example, you can say, what is the time complexity for 25% of the elements? Okay, that might turn out to be better. But the tackle point is to fix this big O, so that I can, for any algorithm, can I improve my worst time complexity? And this is what all this course is going to be about, that we will be looking forward. Okay, you might at times you will write code and you will say, I'm able to get the output through this particular time complexity only. But no, that is not the scenario. We have to make sure our code runs and minimizes the time complexity for the big O. So I hope this explanation is clear to you. Again, we are still in the theoretical part of this particular course, but I wanted you to understand these three representations which are present in DSA. So go and little bit read about them. There are further complex algorithms to explain all these three things, but I'm not going too much deep right now there. Like for example, this is generally merge sort algorithm, basically fall under this category. And there are different kind of scenarios. So, but we will speak about them as we move forward in the course. So thanks for watching this video, and stay tuned. Please subscribe to our channel, and we will be coming up with the lecture 4 very soon. So thanks again, and have a good day.